Thank you. First of all, it's an honor and a privilege to be here. So thanks for organizing this this very wide and rich meeting and for the invitation to be here. So we just heard about how images are made. We heard yesterday in Klaus' talk the enormous feat of creating the EROs. And I'd like to bring the discussion a little bit further. So I picked this provocative title for the pitch. So it's a question, and I even put a conjunction at the beginning, which you should never do, for emphasis. So, but are the colors real? And question to you, the room. So, how many times have you been asked this question in public talks or on social media? Show of hands. At least once. Yeah, at least twice. So I believe it's many of you must have received it quite often, depending on how many talks you've given after the EROs and how often you're on social media. I collected some impressions from the media, so it's definitely a very present question on in the news and on forums. And yes, of course, there's the fake word that pops up, but I think that there was an interesting spin in the way that this was covered right after the EROs, and it went on. There's also an article I picked from the Italian media, and it went on not just with the EROs, but all the way later with further publication of images. So even with the pillars, when the pillar application came was published, and I think so. This question has been asked a long time for Hubble images, but around JWST, I think that something happened that science communicators must have done a really good work in explaining that this is an infrared mission. So the observatory received light that human eye cannot see, and so how are we able to see these images? How are these images created? And to me, this is a result of genuine interest that we shouldn't dismiss. Of course, we should not call the images fake or false color, and I think this is very well known in this room, but not really in not all scientists who give public talks. I've heard it used on several occasions, and it gets picked up by the media and then triggers these questions. But I think this is an opportunity to go in depth, and as we've seen with Lars's talk, with Klaus' talk, take an opportunity to explain in depth not just the astronomical aspects, so how the objects, the astronomical objects are made and their physical processes, how they work, and how each emission traces a different component. But even something, and there are very good, amazing resources. This is just an example of an article from the Webb team explaining how the images are made. But even further, I would say this allows us to tackle something more like a skill, an important skill for the current age, which is data literacy and digital skills. So teaching how images are made is talking about data, but through the back door. So it's not like a coding class, but it's still the excitement of astronomical images, the universe, and yet putting in some deeper content. And this is an example. There are many examples available. This is from the Rubin Observatory education website. It's a resource called Coloring the Universe. And I really like that they introduce it blockwise. So first with regular digital color photograph, and then moving on to astronomical images. It's also something that triggers the interest of artists. So this is an example from Melanie King. She's a British artist who's been investigating how astronomical images are made, and this is with Hubble data. A few years ago, she created this lenticular print, which is a print on a zigzag texture, including monochrome and color image. So to show the mediation, the levels of mediation that are involved in production of these images. And of course, there are other ways to show this, to map a data cube, not just into images, there's sonification. So by the Chandra X-ray communication team together with the System Sounds project, and they included already JWST images to their collection of sonification. So sonification is we're much newer to sound than images, so there's not such a well-polished grammar as the one we've seen for creating color images. There's still a lot of discussion of which parameters to map, which astronomical parameters to map into sound, but there's also a lot of potentiality, more potential, more opportunities, because sound has more parameters. So actually, I just wanted to flag this paper, which came out a couple of years ago on sonification for astronomy, also for research, not just for public engagement. And then I wanted to flag a resource that was developed by two early career researchers here in Italy, which is a motion sensing sonification experiment. It's machine learning powered, and it consists of a camera that tracks your motion, the motion of your hand, actually. You can see it in this video, you hear it as well. And it models the position of the head with respect to the image projected on the screen. So you can do it in real time, and we have it actually at an exhibition that is here in Rome for those who are interested. It's Time Machines here at Palazzo Esposizioni, Roma. So for those of you who are staying on Friday or the weekend, I kindly invite you to visit. And I would like just to close with a shout out to another project that I'm involved with, which is run in Brazil, actually. And it's a co-production, co-creation of scientific knowledge in a favela of Rio de Janeiro, also in collaboration with artists there. Here you see Denise Gonçalves. She's a planetary nebula researcher sharing her work exploring images of planetary nebula with the local children in the Library Cultural Center where the project is hosted. This was it was funded by the IAU Office of Astronomy for Development, and it's an example of reaching out to marginalized community, meeting them where they are, and co-designing together with the community based on their needs and not ours. And also, of course, showing role models of scientists that look like the community. So I would like to leave you with the project motto, and